Alright. What's up mga chimek? So welcome to our final topic this semester, no? The different gas laws. So we are going to talk about the gases and how do they behave. And to begin our discussion with gases, of course, supposedly if this is a classroom discussion, I would be asking you, where can we find gas? And then students would be raising their hand and then they will recite, sir, gas is in the stove, gas is in the balloons, gas is in our classroom. And then one will say, gas is everywhere. And then the teacher would say, exactly, gas is everywhere. It's all around you. It's even in other planets, no? There are gases in other planets. So gas is everywhere. That's why it's important to study and understand how do they behave. And to understand that, we have various, no, or quite a number of laws that would explain how do they behave. And to begin with, we will talk about the Boyles Law. So si Boyles Law, yan, yun yung law kung paano magpakulo ng tubig. Charot lang. So Boyles Law is the law named after Robert Boyles, and it shows the relationship between the pressure and volume. So we'll be talking about pressure and volume for this specific topic, the Boyles Law. So P, capital letter P and capital letter V for volume, because small letter b would be velocity. So for this particular law, we'll be using uppercase letters for P and V. So si Boyle's law states that for before I state the law, let's have an example. So imagine you are pressing a balloon, no? You are actually pressing a balloon inward. What do you feel after pressing the balloon? Of course, you feel that the balloon is somehow resisting. It's somehow pushing against you. That's Newton's third law of action-reaction, right? In gases, what is happening, aside from the gas molecules pushing against your hand, is that as we decrease the volume, so as we lessen the volume by pressing it, so pinapaliit natin yung volume, the pressure increases. So this is an inverse proportionality. So our first relationship of gases between their pressure and volume, they are inversely proportional. So what are the other examples of this relationship? Say for instance, ano pa ba mga pwede nating example? Halimbawa, you are pushing a bakuna, what do you call it, a syringe. But the more you lessen the volume of a gas in a syringe, let me try to draw it for the visuals. But don't judge me, I'm not a drawer. Drawer. Ayan, syringe, kunwari. Tapos ito yung push button. Okay. And the gases are here. So let's say there are 6 gases. And here's the push of the syringe. So if I push the syringe inward, so ito na yung mangyayari. So this is the syringe before, this is the syringe after. Sige, let's make it smaller. 1, 2, 3, 4, 5, 6. So the gases, no, if we can recall, no, the very first topic in chemistry, states of matter, gas are compressible. So we can compress them. However, gas are also moving, diba? They have the kinetic molecular, force. No, they continuously move. And by moving, they either bump into each other or bump into the walls of the container. Therefore, here, they would hit the container more often as compared to here, because the volume here is greater as compared to the second one. And that hitting of the gas molecules hitting the wall is what we call the pressure. This is the pressure of gases. So, the more we lessen the volume, the pressure increases, no? The more we decrease the volume, the more the pressure tremendously gets, no? So, meaning, again, I'd repeat, for the Boyle's Law, as the volume decreases, so that's an arrow down, the pressure increases. Right? That's their relationship. So, ano pa yung mga common example so that we can all relate? Say, for instance, when you were a child, no, if you're not a rich kid, if you're in the streets along with your little gangs, you might have experienced throwing lighter. Diba? Lighter with a compressed gas in it, if you throw that, of course, the gas molecules inside would break. Or even you've played your parents or your sister's hairnet spray, no? Kahit anong spray, yung nasa lata, Baygon, di ba? Nakasulat doon, do not throw in the fire. No? Pero ikaw, yan, dahil kulitis ka, tinapon mo sa fire, it would explode because the pressure there is increased. Very common and very dangerous example is our gasol tank, no? Imagine a gasol na walang laman, 'di ba? We could carry it, no? If you have tried, no, kung tumutulong ka sa bahay mo, kung na-experience mo walang laman yung gasol, ang gaan-gaan niya, 'di ba? Pero imagine we just added gas. No, gas na akala natin weightless, but it's a compressed gas. No, meaning gas in a very low volume with a very strong pressure, it becomes heavier. And yan, one wrong move, 'di ba? If you will try to shoot it with a gun, it would explode. Yeah, because the gases inside are very excited. They're trying to escape in that very sealed container. But I'm not saying that you do that at home. No, nor you throw that Chilean or gasol in fire. So that's just to illustrate how the pressure and volume is related. So that is our Boyle's Law. Before we give some specific examples with numerical values, I have read and watched that Boyle's Law was not actually Robert Boyle's work. Diba? This is one of the greatest misattribution in chemistry, and we like to give the credits to whom it's due. So Robert Boyle was not actually the creator of the Boyle's Law. It was created, no? Boyle's Law has a friend, Richard Townley. And nag-usap sila privately, maybe over some coffee. And then, eventually, Boyle agreed with Richard Townley's. No? So, he published a paper saying Townley's, the title of this relationship is Townley's hypothesis. However, because of his popularity in chemistry during his time and his wealth and his power, it was named Boyle's Law. But the underlying mystery there was that Townley's hypothesis is not even Townley's. It was from their family physician, a working class scientist, meaning not that aristocrat, not that rich, not that powerful, named Henry Power. So si Henry Power talaga ang nag-experiment sa relationship ng pressure and volume. And then, nakwento niya lang kay Townley, at ito naman si Townley, kinuwento kay Robert Boyle. Si Robert Boyle nag-publish, ang pangalan is Townley's hypothesis, and eventually pinangalang Boyle's Law. But nonetheless, no matter who created it, or no matter whom it was named after, no, this relationship is a very important relationship in chemistry. If the temperature and the number of moles of gases are equal, no, or are constant. So let's put that into practice. So here, no, let's formalize the equation. Sabi ni Boyle, if we multiply the pressure and volume, no, of something, it will be a constant, no, always a constant. That is the relationship of the pressure and volume in a constant temperature and in a constant number of gas. So PV is equals to K. So meaning if we have an initial volume, so for the initial volume, we'll be using P1 V1. And for the final volume and pressure, we'll be using P2 V2. It would look like this. No? The initial pressure and the initial volume is equals to P2 V2. Alright? P1 V1 is equals to P2 V2. Some books would use PA VA, PB VB to indicate that it's the initial and the final. Some would use PI VI and then PF VF. No, but for our synchronization and uniformity, we'll be using 1 and 2 as initial and final. So how do we use this equation into practice? Now, how do we use the inverse proportionality of Boyle's law into practice? So let's have an example. Now, say for instance, you have a sample of gas, no, at 1.70 atm. So 1.70 atm. I will no longer write the sentence because I only have one small whiteboard. So I have 1.70 atm. At 1.70 atm rather, I have let's say 4.25 liters of gas. 4.25 liters of gas. And then suddenly, the pressure of gas increased into 2.40 liters, 2.40 atm. So from 1.70 atm pressure, the pressure inside becomes 2.40 atm. What would be the final volume, or what would now be the volume? So we are looking for the V2. So if these are the given, draw calculator. May calculator, sister. Paabot kang calculator. So if this would be the given, this will be my P1. This will be my V1. And then this will be my P2. Alright, now, how do I use, thank you, my little brother. How do I use my, what do you call that? The equation of Boyle's law into this kind of problem. So first, let me write the formula. That's P1 V1 is equals to P2 V2. And then I am looking for V2. No. Sounds familiar? So, we've been all looking for him. Charot lang. So, V2. P1, V1 is equals to P2, V2. So, simple mathematics manipulation. That would be, we divide both sides by P2 to isolate the V2. And there you have it. Now, we'll be having P1 V1 over P2 is equals to V2, the second volume or the final volume. Now, please join me as we input this in our calculators. So that would be P1 1.70 atm. Oh, do not write the value first, no. 1.70 times 4.25 liters divided by 2.40 atm. Alright, cancel pala to. So that would be, what did you get? V2 is 3.01 3.01, and the unit is, of course, magka-cancel. Sige, lagay natin dito tuloy yung ating values a while ago so that we can see the cancellation. 1.70 atm times 4.25 liters over 2.40 atm. That's our V2. Cancel. Liters would remain. The final volume would be 3.01 liters. Now, let's check if that agrees with our rule, no? That as the pressure, our rule for Boyle's Law, diba? It's inversely proportional. So, we can also say that as the pressure increases, the volume would decrease. So here, we increase the pressure. Let's check if the volume decreased. 4.25 liters, 3.01 liters. And there you go, it decreased. There you have it, no, the application of Boyle's Law. Alright? Sige. For your task today, try to solve a similar problem, Boyle's Law. Now, say for instance, it's your best friend's party and you have a balloon, no, a very, very big balloon, for him. And the balloon says, let's say it's in liters. It has 20 liters of helium gas. 20 liters of helium gas. Now, at constant temperature, at constant number of moles, the pressure inside is, say for instance, 3 atm. So, the pressure inside is 3 atm. So, lagyan ko na ng P1, V1. And suddenly, you decided to decrease the volume of the balloon so that it would not explode because your best friend is heavy. No, baka higaan niya yung balon. So, linagyan mo ng room for breathing. So, you change it to 15 liters. What would be the final pressure, no, at constant temperature and number of moles? So, use the Boyle's Law to solve this particular problem. Comment down your answer, and then you have a great day. Enjoy.